Hi, and welcome back. We are in the midst of studying equilibria, and we're working on our acid and base equilibrium. We're going to be doing a base one now. This is the list of how you do it. So if you are a real verbal person like that and you want to read through that, I think it will help. The one thing I have to highlight is you have to add water to the dissociation reaction for a base. We get a little sloppy with acids and just throw off that H+, when really with acids we should be adding H2O, and I just can't get into the habit for some reason. But that's what we would get for an acid. Now we can choose not to do that. It's common to just put the H+ there for the base. Or for the acid, excuse me, but for a base, you have to add water to the dissociation reaction. Now, this is ammonia, and I'm just going to give you the answers for this one so you can work this on your own. pH is 11.33. Your percent ionization should come out to 0.27%. So go ahead and give that one a shot. It'll give you a good idea of what types of questions you want to ask me at the beginning of class. I want to do just a different base because I get really bored with doing ammonia all the time. We're going to do hydrazine. It's N2H4. Now, since bases accept an H+, you must provide the water so that the base has something from which to grab the H+. Now, I've added an H, so that'll be a 5 instead of a 4, and a plus charge, so it'll be positive instead of neutral. And you learned how to write these in the acid-base unit, so hopefully this is just a review. I noticed here on mine there's a bit of a typo. That should say KB there, not KA, so please fix that. The reason is, I think will be evident at the end of this problem. So the KB expression would be my products. You must use brackets, not parentheses, when you're doing a symbolic expression because those brackets mean molarity. Now, once you start your mathematics, I'm okay if you switch to using parentheses. Okay? So remember, it's products in the numerator. We multiply. Again, what's really nice about acids and bases is everything's a 1-to-1-to-1 mole ratio. Now, I have a 0.55 molar solution to start. I have no other source of this and no other source of the hydroxide. Now, I'm going to lose some amount. I'm going to gain product and lose reactant. I don't know how much, so I use the letter B for base. Okay, so then E is simply equal to I plus C. If you hadn't picked up on that, I thought I better emphasize it. 0.55 minus B, B, and B. Now, we're going to neglect that one. And you can't neglect multiplying by a tiny, tiny number, but you can neglect adding and subtracting. Now, the percent ionization is going to be the hydroxide at equilibrium divided by your original base. Now, you can't just put base here. This is about learning to write these expressions explicitly in preparation for AP, because I'm hoping bunches of you take AP with me. So don't just write the word base here. You have to write the formula for the base that we're referencing in our question. So now I have my framework. I'm ready to do the kind of plug and chug portion. Now, to get the KB, that will be given on a test, usually in the context of the problem. For the homework, you'll be needing to look those up in a table. And you have that table as part of your notes packet and or homework packet. I'm not sure if it's one or both, but you have that available. The KB is 8.9 times 10 to the minus 7th. And in place of N2H5, I'm going to put a B. In place of hydroxide, I'm going to put a B because those are equal to one another. And then I'm going to put that over 0.55. Now, you'll want to go through the algebra. For one, I've been known to make mistakes when I do my algebra. And two, it makes sure you understand how to plug this into your calculator and do the algebra yourself. Now B, which remember is your hydroxide ion concentration, it's also this, but it's the hydroxide that will lead us to pH, is equal to 6.99. I'm not going to round yet because I'm not at my final answer. If you are asked for that as your answer, don't forget your molarity. Now, this is why I like to use B. I have too many students simply take minus the log of this number and call it the pH, but it's not the pH. Minus the log of that number is the pOH. So you have two choices here. You can go from OH minus to pOH, and then you can go from pOH to pH, or you can use 1 times 10 to the minus 14th and go to H plus, and then go to pH. Either route is just fine, but it's 2. When you solve for B, remember it's 2 steps to pH. It's the only reason I use a different symbol, and it works. It is a good reminder. It has helped my AP students gain that extra point that they would have lost if they would have simply taken minus the log of that and called it the pH. Plus, we have a base. We expect the pH to be greater than 7. So use your logic as well. I did it the pOH route. pOH is 3.16, which makes my pH 10.84. And indeed, it is above 7, which would be expected for a base. All right, then lastly, we plug into our percent ionization, and that will equal our OH, 6.9964 times 10 to the minus 4th, divided by my original base times 100. And if I've done my algebra right, I get 0.13%. Now, we can talk about strong and weak bases as well. So the one with the biggest Kb wins. The Kb for ammonia is 1.8 times 10 to the minus 5th. The Kb for hydrogen, we just saw, is 8.9 times 10 to the minus 7th. As you increase Kb, you increase the concentration of hydroxide formed or product formed, and you increase the strength of your base. So in this case, ammonia would be the winner for the strong. This asked what the weak is. So if ammonia is the strongest, that must mean hydrazine is the weakest. Read it carefully. So which of the bases is the strongest, which is the weakest? They're both weak bases, but ammonia is the strongest of the two. Okay, we are going to shift gears in our next set of videos and talk about stress. Not the stress that chemistry has caused so many of you for the year, but the stress that can be applied to an equilibrium. And it was discussed by a dead guy named LeChatelier. So until then, this is, you betcha, signing off.